The purpose of this video is to go over 4.4, number 33 on your homework. And there's a couple steps on this problem. And my math lab's a little picky on the rounding, and so you have to be careful on that. But let's go ahead and go through this problem. We're looking for a cost function, and so cost is related to surface area. So I need to find the surface area of this cylinder with a hemisphere on top, which a hemisphere is just half a sphere. So the surface area of the cylinder part is going to be 2 pi RH, so the circumference times the height, plus the surface area of the sphere, which would be, for the sphere, would be 4 pi r squared, but since we only have half of a sphere, it's 2 pi r squared. And on my problem, it says it costs 6 times as much to create the cylinder sidewalls as it does the 6 times as much as the cylinder sidewalls. So if I want to make it the cost function, when I take the 6 in here, that is going to change the surface area into a cost function. So the cost is 2 pi RH plus 12 pi r squared. So now I have a cost function. I notice it's in terms of r and h. So I'm given a fixed volume, so I'm able to write the volume in terms of r and h, and then I'm going to be able to solve for, in this case, h, to get it in terms of r, to be able to plug it in right here to get a cost function only in r. So I'm given that the volume is set at 18,000 cubic units. So later on in my math lab, it decides to make the units feet, but we'll just pretend like we are in feet the whole time, but that's fine. So I need to find the volume of the half sphere, and a volume of a sphere is 4/3 pi r squared. I have half of that, so it's going to be 2/3 pi r cubed. If I gave you one of these on exam, I would give you these formulas, but pi r squared h would be the volume of the cylinder. So this is the set volume. I'm going to solve for solve for h. When I solve for h, I get 18,000 minus 2/3 pi r cubed, all divided by pi r squared. Right? So solve for that, move this term to the left-hand side, divide through the pi r squared. So this doesn't look too pretty. I can clean it up a little bit. R to the minus 2 minus 2/3 r to the first power. So now that I have h, I'm going to plug this in here to get my costs in terms of only my radius. So I have 2 pi r times 18,000 divided by pi r to the minus 2 plus some room here. Sorry, minus 2/3 r. And then I have the rest of it, 12 pi r squared. So cleaning it up, I have 36,000. The pi's cancel, and then I have r to the minus 1 minus 4 pi over 3 r squared plus 12 pi r squared. This point, I can join these two terms together and simplify the cost function in one more step. So I have 4/3, I have 12 minus 4/3 pi, so that gives me plus 32 over 3 pi r squared. This is the function, the cost function, and if I'm going to maximize or minimize, so in this case I want to minimize the cost, I need to find the derivative of that. I want to keep in mind that I want to find the interval in which my function is going to the interval of existence. So if I go back to my h function here, I want to see when does this equal 0. So I wouldn't have a silo if I had a 0 height. So how big can r get? Basically that's saying. So r has to be at least 0. It can't be 0, so it's an open interval. And then I want to solve for when this equals 0, and I can use my calculator to do that. And if I plug that in my calculator, I get r is approximately 20.5, and I want to round that to 1 decimal. And I'll caution you of rounding decimal on sorry about that. I'll caution you of rounding a decimal when you plug in r for h at the end. My computer is going crazy on me. So this is my interval of existence. So now we have the cost function and the interval of existence. We apply the calculus to find the minimum cost. So I'm going to take the derivative of this function with respect to r. Derivative with respect to r. So the derivative of the cost with respect to r. In this case is going to be minus 36,000 r to the minus 2 plus (64 over 3 pi r cubed). So pretty simple power rules there. I'm going to set this equal to 0, and this is going to give me critical points. So keep in mind that r cannot equal 0, so I can multiply both sides by r squared, and that gives me minus 36,000 plus 64 over 3 pi, not r squared, that'd be r to the first power. This would be where my r squared comes in, and then 0 times r squared is still 0. Solve for r cubed, and when I do this, I get approximately 8.128891053. So my math lab's going to say round to the nearest tenth. So 8.1 would be your answer there. However, I caution on the next step you need to solve for h. So solve for h. I'm going to plug this number here back into this h function and then I'm going to do that, and I did this on my calculator, and I ended up with 81.3. Really, I got 81.28 something. If you plug in 81, this could be off. So be careful here. With rounding, my math lab will say round to the nearest tenth. When you go to plug it in, be careful with that because it can give you off. So hopefully this answers any questions you have on this. If you have any more questions, please let me know.